Would it matter if it was like an existential and a universal
Oh,
in the same statement?
excellent question, Taylor. It absolutely matters. It 100% matters. We're not going to get there to the next time.
Okay.
But for now, let's talk about for all statements. So we still have multiple quantifiers. Still have multiple quantifiers. Let's look at a double for all statement. So if you had like for all x and d, and for all y and d, p of x, y. Oh, hello, Mr. Camera. I think we keep writing, it'll go away. So that's just for all x and d, for all y and d, p of x, y. So, for example, we could have every finger on every finger on every one of my hands is a deadly weapon in paper football. There, what if I do this? And then bring it back. Okay. Oh, nailed it. Okay, yeah. So every finger, every one of my hands is a deadly weapon in paper football. Got that flick. Absolute instruments of torture. The point is we can write this, right, as for all, I'll say F and fingers, my fingers, and then for all H. So actually what I'll say here is for all F in the set of fingers, right? In the set of fingers you have what? You have your pointer finger, your middle, ring, pinky, and thumb, right? And for all H in your hands, so I'll say you have left, I have my left hand and my right hand, right? For all that, my F finger on my H hand is a deadly weapon in paper football. So that's our statement. And this right here, this is like our predicate Q of FH, right? So QFH returns true if the F finger on my H hand is in fact a deadly weapon in paper football. It returns false if otherwise, if the F finger on my H hand is not a deadly weapon. So does that make sense? How we got from this to this statement? This is a double for all. It's saying something about every finger on every hand. All right. But let's notice.
I have a quick question.
Hit me.
What if there happens to be overlap within our domains? Like if you hadn't specified the fingers as being like the types of fingers, but just like the amount of fingers that you had, like if it included the fingers on your left and your right hand,
yeah,
how would that affect our statements?
It would affect our statements.
Would they just double?
Because the second one wouldn't really be doing anything.
Okay. Okay.
right? That would be like if we said for all x in the natural numbers, and for all y in the real numbers, x is positive. The y doesn't really contribute anything.
Mm.
I mean, so you could do it. This would be a valid double for all statement,
Mhm.
right? In this case, we have a predicate p of x y just equals x is positive. Right, that's totally fine. But the y doesn't do much. And same thing kind of over here. If I had all my fingers here on the left hand, right hand, the hand just wouldn't contribute any new information. It wouldn't even really be used, you know?
Okay. So it's just overlap when you don't even need it.
Yeah. 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 The point is, though, what if we did this in reverse? So I'll call this set, let's call it S, and I'll call this set big H. How about for all H and big H and F and big S? Is this the same or different from this statement right here? Who's got me? Someone throw out a guess.
I say it's the same.
Same.
I do as well.
Same, right? Because kind of the exact same reason, right? This statement right here is saying that for every single finger on every single hand, right? So my options being like left pointer, right? Those are my options. For any one of those, right? Our predicate's true. Is a deadly weapon in favorite football, right? But if we go the other way, we look at both my hands, and then we look at each finger, we're still hitting we're still making a statement about every single possible finger and every single possible hand, right? So we're making a statement about the same set of things, really. And same thing with the there exists, right? The there exists, we're making a statement about the same possible set of things. So yeah, so another example would be real quick. For all x and evens, and for all y in our set of evens, actually I'll say for all y and odds, x plus y is odd. Total statement, right? The double for all statement. But what this means, right, is equivalent to saying that for all x in odds, or sorry, for all y in odds and for all x in evens, x plus y is odd. Right? So, in general, this is always equivalent. Oh, this used to be a C right here, by the way, because you have different domains. In general, this is equivalent to for all y in C and for all x in D, P of x, y. And here's like the comp sci way to think about this with the for loops, right? This is saying that if you loop over all the x's and d, so you can say, oh my word, what this is saying is that like for all x and d and for all y and d, right? Or for all y and c, p of x, y is true. It's got to be true always. Right? It has to always work. If it doesn't work in any one of these loops, you return false. Right? So if over here is saying return false otherwise, something like that, right? But if you reverse this, if you have the y and c up here and the x and d down here, that's fine. You're still looping through the exact same things, looking at all the exact same data, all the exact same pairs, right, and determining if they make it true everywhere. So it's the exact same thing. And for the existential statements, you can think about it in the exact same kind of way, except instead of for the existential statements, we'd be saying is that for all x and d, and then for all y and c, if p of x, y return true, otherwise you return false. The point being, right, you're looping again, you're kind of looping through everything in these possible domains and just trying to find one that's true. It doesn't matter what order you're doing it, you're just going through all the possibilities of the pairs and trying to find one that's true. So it doesn't matter there, but it will matter when we mix them. That's a conversation for next time. Any questions? All right then, sorry for going over. You guys asked some good questions today. We will do more of this next time. We get into the mixed quantifiers, which are the interesting quantifiers, because all these actually aren't that interesting. We'll talk about why next time too. But anyway, until then, we'll have some fun. Oh,